minimum velocity, all right? A particle moves along the x-axis. You have the position function, and you want the minimum velocity. Brent, can you turn this way? Thank you. Okay, so guys, if you want the maximum or minimum velocity, what test do you use? Candidates. Okay, so if I do a candidates test, you agree that you need a t-chart, you need t over here. Let me ask you again. If I want the maximum or minimum velocity, what goes on this side here? V. Is everybody good with that? So V goes on this side. Let me just go ahead and write it so I don't get confused. It's V. So it's actually not this S function. You agree? It's V. So V is equal to 3t squared minus 10t plus 12. Does everybody agree with me so far? All right. So if you do a candidates test, what do you need on the left side? Endpoints. What are my endpoints? 0 and 4. They give them to you. What else do you need on the left side? Your critical points. But your critical points here are going to be something prime equals 0, right? What prime is going to be equal to 0 here? V prime. Is everybody good with that? Because even when we did candidates test, even on your former 2 tests, okay, whatever way here, if this was an F here, to get your critical points, you would do F prime. Well, if this is a V here, then to get your critical points, you need V prime. Guys, what is V prime here? Which is also 6t minus 10. Is everybody good with that? Okay. Do you guys see that I started with position, and I've already taken the derivative twice? Okay, so you'll see this on your test. I don't remember if it's this test or the next test. But a lot of students mess this up because they only feel like they should take the derivative once. Okay? If you're trying to maximize V, you got to take the derivative of V. If you're trying to maximize F, you got to take the derivative of F. All right. Once I take the derivative, how do I find the critical points? You set it equal to 0 or D and E, or 1 over 0. There are no fractions here, so I'm not going to get any critical points from the D and E. But over here, what I'm going to get is T is equal to 5 over 3. Okay, 6t minus 10, 10 over 6. That's going to be 5 over 3. So I'm going to take my 5 over 3, and that's my critical point, so I'm going to put it over here. Then what I'm going to do is I'm going to fill in this candidates test. But guys, when I fill in this candidates test, what function am I going to use to fill in this candidates test? V. Some of you guys are leaving out, what goes on this side. Whenever you label your number line, you're leaving out what the number line label is. Guys, it's going to become really important on motion that you plug into the right equation. So let me take my calculator out. I'm going to go ahead and clear my calculator. And guys, I'd like you to work with me also. You shouldn't be surprised on your test when you have calculator problems, okay? You should be just like, oh, goody, I get to use my calculator, okay? There are problems on your test. I think this test might be an all calculator test, okay? Like you can use your calculator for the whole time. I'm not 100% sure, but I'm pretty sure. And if it is, that makes it harder in a way, because what that means is that I don't tell you when you can use your calculator. And when you're stuck, you need to know when to use your calculator, okay? And so there was a problem on your homework, I think, that some of you guys should have gotten stuck on. And when you got stuck on it, you should have said, oh, I can use my calculator, okay? I think it was I want to say it was might have been number 4, 6, okay? All right, so guys, take a look at this. I want V in here, so on y equals, I'm going to put my V in. So that's going to be 3x squared. Let me move this over. That's going to be 3x squared minus 10x. Okay, and I'm smarter than my calculator, okay? So instead of x, I'm going to put in t, okay? I'm a little tricky that way. I'm cheating on my calculator, okay? I'm using x's instead of t's, but my calculator doesn't know, okay? But it still turns out to be the same, okay? And what I want to do is I want to do this candidates test. So I'm going to go in here, I'm going to go to second table set, and I'm going to change my auto to ask. And what that does is when I hit second table, I get a whole blank table to work with. And I just duplicate my candidates test right here. My first x is 0. My next x is 5/3. My calculator is so smart. I just put in 5/3, hit enter, and it knows what to do. And I hit 4, enter, and I've duplicated my candidates test here. And so all I have to do is copy these numbers right into my chart. So my question is, what's your maximum velocity? So your maximum velocity is 20. When does that occur? at t equals 4. What's my minimum velocity? 3.666 or 3.667. And when does that occur? Okay, any questions on my answer? Guys, if you are asked to justify this, okay, how do you justify this answer? It's already done. Is everybody good with that? It's already done. And I can't tell you how many people on the test wrote all these words. Please see candidate's test on the left. First, I plugged in the critical numbers. Then I put in endpoints. Like, you don't need to explain anything to me. Does that make sense? The justification is the candidate's test. But the candidate's test, of course, must be complete. It must have all your critical points. It must be all your endpoints. You must have the right numbers here. Okay? Then it's a correct justification. Okay? If your candidate's test is wrong, then of course, it's a wrong justification, all right? But guys, please do not write a lot of words when you don't have to have a lot of words, because if you start rambling and you write a sentence that is untrue, does that make sense? Then your problem becomes wrong. You stated something that was untrue, all right? So make sure you don't start rambling, okay? All right, there is another way, so let me get rid of this calculator. There is another way to find absolute max and min. You agree with that? That is using the which test? First derivatives test, okay? Right? It's just that the justification is very difficult. Do you remember this one? Okay, and that's what we're going to use for optimization. So it's worth going through this practice, doing it, even though we've done it this other way, to figure out how you find the max and min, absolute max and min, using a first derivatives test. So here we go. What you do is whatever you're trying to take the maximum or minimum of, you take the derivative of it, you find the critical point, so we've done all this, okay? You test now, you do an F prime number line, and you test to the left and right of this 5/3. What's a good number to the left of 5/3? 0. What's a good number to the right of 5/3? 212. All right. If I plug in 0, what function am I going to plug 0 into? I'm trying to maximize B. B prime, or A. Does that make sense? Okay. So here's my function here. I'm going to plug in 0. Do you get a positive or negative number? Okay, what if I plug in 212? Positive. So what happens is I get decreasing, increasing, and that's a picture of my V, right? Because if this is my F prime, isn't that a picture of my F? Right, same thing that we've been doing. All right, guys, look at this. There's only one critical point, and to the left of the critical point, the slope is always negative. And to the right of the critical point, the slope is always positive. So therefore, this must be my what? It is my relative min, but therefore it also is my absolute min. Do you remember that justification? And that's what we're going to use for optimization, which we're going into today. This is my absolute min. So what that means is that the justification could be, I only have one critical point. Okay, that critical point is at t equals 5/3. Okay, when t is less than 5/3, okay, my derivative, my b prime, is less than 0. When t is greater than 5/3, my b prime is greater than 0. Therefore, okay, I know this justification is terrible, but you had this on your test. Anyway, those of you guys who didn't do a candidate's test. Therefore, there's an absolute min at t equals 5/3. And of course, I can find the velocity too by plugging in. So the velocity is 3.667. All right, any questions about that? Guys, you can also find absolute max with this. Okay, how do you find absolute max with this? If you only have one critical point, and the slope here is always negative, and the slope here is always positive, think about what the picture looks like. Where is my max going to happen at? Endpoint. Does that make sense? If you have a parabola and it's happy, your maximum is always going to be at the endpoint. If you have a sad parabola, your maximum is always going to, or your minimums are always going to be at the endpoint. Does that make sense? Okay, so the justification for absolute max here would be you have to repeat all of these things. You'd have to repeat all of them again. Okay, then you'd say third. Okay, because of all of these things, the absolute max must occur at the endpoint. And I know my English is not very good here. One, it's because I'm an immigrant. Two, it's because you don't have to have all those words. You just need some key words that they're looking for, and just have those key words. Okay? All right. And so then you have to say, well, which maximum is bigger? So what you'll say is f at 4 is bigger than f of 0, meaning that your 20 is greater than 12. So therefore, you have an absolute max at well, it's at t equals 4 or at b equals 20. Okay, that is your justification. Okay, do you need to know this justification? Well, if you're planning on not using candidates test, yes. Okay, more than likely they're not going to tell you this absolute max. You won't go all the way here. More than likely you'll have an absolute min. Does that make sense? Justification. They'll probably stop there. I mean, I can't say, I can't say for sure because AP can do whatever they want. But I would say typically they would not make you go this far for an absolute max. Okay. All right, but we'll be using that today in optimization. Go ahead and pass up your warm-ups and let me get questions from you guys. Let's look at homework, guys. Can I go ahead and get questions from you guys on homework? Yeah, guys, it was number 4 here on your homework last night. If you had trouble taking the derivative of velocity, because to find acceleration, you need the derivative of velocity. All you had to do was go into your calculator, do a math 8 on this function at time 3, and whatever the calculator spit out, that was your acceleration. And guys, there's a similar question on the test. I'm just letting you know. Some students do all sorts of things, but sometimes if you cannot take the derivative, you would just use your calculator, because you have your calculator sitting next to you. Okay? What questions do you guys have on your homework? Oh, motion 1 or motion 2? Any questions? Were you able to draw the acceleration graph given the velocity? Could you do that? Yeah. Okay, Miriam?
On motion 1, yeah. Number 2, E.
Okay, so motion 1, number 2, E.
Yeah.
Does it look like this? Is it this one? Okay. So you're asking how to take the second, you had to take the derivative.
I didn't like it.
Yeah, you didn't like it. Okay. Did you look at the notes? I can do it with you.
Yeah.
Okay, I can do it with you.
I didn't look at it yesterday, so I probably can just do that.
Okay. Are you okay to looking at the notes? That way we can save some time.
It just had the answers.
Yeah, okay. Yeah, it's posted, sorry. The notes are posted, the solutions are posted now.
Okay.
So you can take a look at that, Mary. So you just, it's taking the derivative, and I agree, it was kind of messy in here. So, okay. What other questions do you guys have? Okay, let's move on then. Let's go to optimization. And guys, if you want to do this problem with me, it just takes a long time, so I'm happy to do it after school, or go over it yourself and then ask me questions. That way we can save some time in class. But I'm happy to do it after school. Okay, let's look at optimization. And let me just define optimization first, okay? Guys, optimization just means find the maximum or find the minimum. That's what it means, okay? And in real life, there's a lot of optimization going on, okay? As a matter of fact, if you really like this unit, you can actually major in either engineering or in math, and all you would do is optimization, okay? Because there's a lot of applications to optimization. So let me give you an example. The airline industry, okay? The airline industry, they're always trying to maximize and minimize things, okay? And they always have constraints that they have to live with. For example, what do you think an airline industry would try to maximize? Like profit or fuel efficiency, okay? And so let's say one of their equations would be maximize profit. But in order to maximize profit, okay, you also have to minimize the cost of fuel. Does that make sense? And in conjunction with that, you have a lot of constraints. The pilots have certain schedules that they have to abide by, right, because of their union, okay? The mechanics need a certain amount of time. Every time the plane is down, the mechanics need a certain amount of time to do whatever they do to the plane. Fix the plane, fix the mechanical problems, rotate the tires. I don't know what they do to the plane, okay? But all these things that the mechanics have to do, you have to give them time to do that, okay? At the same time, the lunch crew needs to come in, right, and do all these things. So it's basically like a logistical nightmare with like 5,000 variables like coming in, right? So they have, the airline companies, they hire these computer programmers, okay, and also mathematicians, okay, to figure out all the equations that go into this thing. And it's a bunch of derivatives at one time. It really is. It's a bunch of calculus to actually maximize their profit or minimize their use of fuel or maximize their fuel efficiency, okay? In our problems, all we're going to do is maximize or minimize one thing, okay? But in real life, you have lots of dimensions that you have to maximize, okay? In our problems, we're just going to have one constraint. But in real life, you maximize and minimize a ton of things, and on the side, you have a ton of constraints, okay? So these are going to be simple. You probably won't think they're simple, but compared to real life, they are simple. Okay. First of all, I want to find two positive integers or positive numbers whose sum is 20, whose product is large as possible. So the first thing you do, and you guys have in your notes, you can follow with me, okay, is you're going to maximize your product. Okay, everybody good with that? I'm going to call my product P, okay? If you're trying to maximize your product, what you need is an equation for product, okay? So my equation here is going to be multiplying the two numbers, right? Product equals X and Y, okay? But if you maximize your F, you're going to have to take the derivative of F, right? So if you maximize your P, you're going to have to take the derivative of P. And can you see I have a product rule happening in here, okay? For these problems, I'm just going to let you know that you can change all of them to one variable so that you don't have to do product rule, okay? And the way you're going to do it is you're going to go and look for a constraint. So this constraint here is that all your x's and y's have to add up to what? 20. You see your constraint. The sum is 20, okay? And so what you're going to have to do is you're going to maximize your p, but your sum of your x and y's have to be 20. So what you're going to do is you're going to solve for x or y here. So let me just solve for x. It actually doesn't matter which one you solve for. At home on your own, if you'd like to, you can solve for y and see what happens, okay? And then what I do is since I've solved for x, I can actually plug in, okay, plug in my x right here. So this is what x is. I'm going to plug it in right there, okay? And so what I get is an equation that now has only one variable, and so I don't have to do product rule. Does that make sense? Okay, this is just avoiding the product rule, okay? So I know a lot of you guys avoid lots of things, product rules, trig, homework, okay? But what I want you to do is you can avoid it. You can avoid it by just putting in your constraint. Okay, here's where students have trouble. They've got their equation and they just get stuck, okay? Guys, if you get stuck, probably try and take the derivative on all of your problems, okay? That's all we're learning anyway, right? So we're trying to maximize P, so take the derivative of P. Now, this is kind of like a related rates problem, in that we're going to take the dy of both sides. It's better than a related rates problem, though, because we're not doing rates, okay? So you don't need to introduce a t. You just, whatever letter you have, you just take the derivative with respect to that letter. So here we have y, we'll just take the derivative with respect to y. So because of that, I just changed my prime. I don't leave the y because it's not as super important as it was in related rates. And this will be just 20 minus 2y. You guys see how easy that was. Okay, it's a little bit easier than related rates here. Okay, once you take the derivative, what you're going to do is set your derivative equal to 0, or you set it equal to dne. Okay, over here I'm going to get no critical points for the dne just because I have no fractions. Over here I'm going to get y equal to 10. All right, so basically I'm done with my problem. Okay, what I do now is I have a critical point at y equals 10. I'm going to do a number line, a p prime number line, or an f prime number line. Okay, I'm going to plug in numbers to the left of 10 and to the right of 10. What's a good number to the left of 10? 0. What's a good number to the right of 10? 212. All right, now what equation am I going to plug in? P prime. Okay, guys, some of you guys are leaving out your primes. Make sure you include them. The names of your number lines, very helpful to figure out what to plug in. If you plug in 0, do you get a positive or negative? If you plug in 212, do you get a positive or negative? All right, so this will be increasing, decreasing. If this is my f prime graph, then this is my f graph. Does that make sense? This is what my p graph looks like. So what's happening at p? I will have only one critical point. To the left of that critical point, my slope is always positive. To the right of that critical point, my slope is always negative. So what's happening here? An absolute max. Does that make sense? Now, does it say justify up here? No. So you actually don't need to justify for these problems if it doesn't say justify. But you need to know what's going on behind the scenes, right? This is what's going on behind the scenes, that there's an absolute max here at 10. All right, so if there's an absolute max at 10, y is going to be 10. What's x going to be? Yeah, x is going to be 10. You just go back to your constraint. You see that x is 20 minus y, so therefore x is equal to 10. Okay, and then make sure you answer the question. The question is, find two positive numbers. I did it, so I'm in good shape. Okay, let's do another problem. All right, this is a similar problem. It's just now they've added an application to it. You've got a rectangle. Okay, got a rectangle, and I'm going to label my rectangle as X and Y. You can do B and H, do whatever you want. Just don't do what some of you guys did on the test, which was to make a triangle instead. Okay, all right. So this is a rectangle, and the question is, they want you to maximize the area. Okay, so I'm going to write maximize area here. Guys, what that means is I'm going to take the derivative of area. So what students do wrong is they take the derivative of the wrong function. Okay, whatever you want to maximize or minimize, that's what you're going to take the derivative of. The other part is just going to be a constraint. All right, what's going to be the equation for area here? XY. Okay, I have two variables. I'd like to change this into one. I go look for a constraint. Here's my constraint here. Can anybody see what that equation is for the constraint? The perimeter is 34. 2 times x plus 2 times y is 36. Okay, what you want to do is solve for x and y here. It doesn't really matter. Just to simplify, guys, I'm going to divide everything by 2 first, and then I'm going to solve for y. Again, guys, it doesn't matter which one you solve for. It'll work either way. Sometimes one is easier than the other. Sometimes they're both equally easy. Okay, then I'm going to take this y here. I'm going to plug it in. So I get a equals x times 18 minus x. Okay, and that helped me to move this to one variable. Okay, and so now I have a is equal to 18x minus x squared. And again, this is where students get the idea what to do next. Take the derivative. If you haven't taken the derivative, heck, just do it. Okay, even if you don't know what to do afterwards, chances are you will once you take the derivative. Okay, we're going to set it equal to 0, or you're going to set it equal to d/e. That's what you do to maximize or minimize. Okay. The d/e side, I have no critical points just because I have no fractions. Over here, I'm going to get x is equal to 9. Is everybody good so far? Okay. If I do a number line, it would be an f prime number line. So that would be an a prime number line. I would put in my critical point, which is 9. Okay. Test my intervals. Okay. Let's do 0 and 2, 12. Which equation would I test it in? The a prime equation. If I plug in 0, do you see I'll get 18? If I plug in 212, do you see you get negative 184? Just kidding, I have no idea what you get. Okay, but you get something negative. All right, so this means increasing, decreasing. If this is a picture of my f prime, then this is a picture of my a. Guys, if I have one critical point, and at this critical point, okay, to the left of it, your slope is always positive. To the right, the slope is always negative. What's happening right here? An absolute max. Did they ask me for absolute max? Why, yes, they did. And just FYI, if you only have one critical point, I don't expect you to do this. Okay, you don't have to justify. But if you justify just to make yourself feel better, which I do, okay, then you know that there is really an absolute max here if you use this 9. Okay, so let me go ahead and use the 9. If x is equal to 9, what's y equal to? Okay, so that's 18 minus 9, which is 9, which is interesting because that means if you maximize the area of a rectangle, what do you get? A square, which is interesting to know also. And then did I answer the question? Did I answer the question? The dimensions are 9 by 9. Okay? All right, you guys good on that one? Okay, it's going to get more fun. Here we go. You have this problem right here. Okay, what you have is this river. Okay, you're going to build a fence along the river. Okay, but you're not going to put the fence where the river is. Okay, you're going to just like build in an enclosure, but you're not going to put a fence right here. Does that make sense? The enclosure, like one side of their enclosure is your fence. All right, they're asking you to maximize what? Area. Everybody good with that? So I'm going to take the derivative of area, but first, what's the equation for area going to be? Well, if I label this x and I label this y, you guys with that? Or would you rather have BH? It doesn't really matter. BH. Okay. All right. You can thank whoever was it Avery? I don't know who it was. Okay. You can thank Avery. Now it's changed. Okay. Obviously it wasn't Avery. Okay. So you could say the area is BH. Was it FB? Annoying. Okay. All right. So just kidding. All right. Annoying to Avery. I'm trying to speak for Avery here. Okay. So BH, there's two variables here. How do I get rid of one of them? Find your constraint. Okay, let's go find my constraint. I have 800 meters of fencing. Do you see what my constraint is going to be?
Yeah.
What is it?
It's a perimeter.
It's a perimeter, but does the river count?
No.
No. So it's 2H plus B equals 800. Does that make sense? Can you do that on your own? Okay. Which is easier to solve for, B or H over here? B. So let's just solve for B. Okay, B is equal to 800 minus 2H. So then what I do is I bring over the B here, 800 minus 2H, quantity times H. Okay, then I only have one variable. Is everybody good with that? What's my next step? Distribute. Okay, so I'm going to go ahead and distribute. You didn't want to do product rule?
No.
Okay, that's fine. You can distribute. Okay, and then what's my next step now? Take the derivative. Very good. Again, guys, this is where students forget to take the derivative. Make sure you actually take the derivative. As a matter of fact, if you finish your test early, go back over your whole test and make sure you took the derivative in each problem. Does that make sense? If you didn't, you probably did something wrong. Okay, so the derivative is equal to what, guys? 0 or D and E. On the D and E side, I'm going to find no critical points. On this side, I'll get H is equal to 200. Okay, so let me go ahead and write that in my picture. H is 200. When H is 200, can I figure out what B is? It's 800 minus 2 times H, right? So B is going to be equal to, are you guys getting 400? Yes? Okay, so B is 400. Now be very careful. Did I answer the question?
No.
What was the question?
Area.
Find the area. So guys, the answer is not 200 by 400. What's the answer? 80,000. Okay, is that not right? Yeah, 200 times 400.
Yeah, that's what I got.
Okay, what do you think it is? Do you think it's 8,000?
You're good.
Okay, I want to tell you, I mean, these zeros are kind of confusing. But if I ask you for units here, could you give me units? It's area. Okay, so make sure that you can actually add the units on if they're asked. All right? Okay, let's do the parabola problem. Here we go. Go ahead and draw your parabola. It's going to help you guys out. Oh, it's already drawn for you? Oh, that's nice. Oh, you already drew it. Okay. So what I want you to do, oh, it is drawn for you. That was really nice. Thank you, Ms. Chang. You're welcome. Okay, so right here, guys, it says find the area of the largest rectangle with the lower base on the x-axis and the upper vertices of the parabola. Guys, on your test, you are not going to have this drawn for you. Does that make sense? So make sure that you understand. That means the base is down here. Okay, that means your parabola points. Does that make sense? The upper rectangles touch your parabola. That's your parabola points. So you have a rectangle like that. Okay. Here's the tricky part. Label your x's and y's here. Label. I guess what I say is label the bottom of your base and your height. Label your base and height here. Because you see your variables are already given to you. You have to use x and y. You don't want to introduce another variable. Okay? So see if this makes sense, guys. This right here is 2x, and this right here is y. Do you guys see where I got the 2x?
Yes.
Because x is already defined in this problem. You know, x is the distance from the y-axis to the right. Does that make sense? So this distance here must be 2x. But y is from here going up, right? So this distance here is y. Okay, so make sure, guys, you know how to label these x's and y's. All right, what are they trying to tell me to maximize or minimize here? Area of the rectangle. So I'm going to maximize area. And what is my area of the rectangle? Be careful. 2xy. Okay, all right, and then I need a constraint because I don't want two variables here. What's another equation that I can use to get rid of either the x or the y? Well, by golly gee whiz. Check that out. Okay, it's already here. So what I'm going to do is I'm just going to plug that in. 12 minus x squared. Okay, now I have one variable. You guys want to do product rule? No? Okay, then let's go ahead and multiply, distribute. Okay, what do I do next? Go ahead and take the derivative. Very good. So a prime is going to be 24 minus 6x squared. Set that equal to 0, or set it equal to D and E. On the D and E side, because I have no fractions, this is going to be no critical points. On this side, I'm going to get x squared equals 4, so x is going to be plus or minus 2. Do you see how the plus or minus 2 works out here? Look, this is minus 2, this is 2, right? It works out on the graph, okay? All right, guys, what are they trying to ask me anyway? I need to figure out what they're asking me. If my x is plus or minus 2, what's my y equal to? 12 minus 4, right? You guys getting 8? Okay, did I answer the question? No, what was the question? To find the area. So guys, what's the area of this thing going to be? Ooh, be careful, look at your picture. It's 2x times y. So what is it? 32. Are you guys getting 32? It's 2 times x times y. So that's 32. Okay. I was going to say something about this. Do you guys see how I got more than one critical point here? So it's actually kind of interesting. Like I told you, you didn't have to justify, but it's kind of interesting to justify here to see what you get. If you actually justify here and you put in your points -2 and 2, and let me try some points here. If I put in -212, no, let's do negative, no, let's do -5. If I put a -5 here, try 0 here, and try 212 here. What equation am I going to plug this into? My a prime, right? So here's a prime. If I put in -212, do you see I'll just get a giant positive number? Okay, so what will happen is I'll get negative over here. And then if I plug in positive 212, I'll also get a giant negative number. So that's going to be negative over here. And if I plug in 0, I'm going to get 24, so that's going to be positive over here. So this would be decreasing, increasing, decreasing. Okay, now let's think about this. What did they ask me for? The maximum what? Area. So guys, if this is a prime, this is a. So where does the absolute max of area occur? Right, it's going to occur right here at your 2. It could occur at the endpoints. But if you think about the endpoints, this endpoint here is what? When area is 0. When is this my x or my y? I forgot. My x. It's when x is 0. Or guys, if x is 0, what's going to happen? Like you're not even going to have an area. Does that make sense? So you would just like disregard that answer. This will be your absolute max. All right. Again, you don't have to justify. We just did that for fun. Wasn't that fun?
Yes.
Okay, that's what I thought. Good answer. Okay, let's go to this problem here. Did I draw this for you?
I wish.
Okay, go ahead and draw it then. Okay, guys, this is really useful in real life, guys. What we're going to do is we're going to minimize the amount of paper we use. But guys, you can do the same problem, and for your English essay, you can be like, what area do I need to use here to minimize, you know, like to trick my teacher and make it look like I wrote a lot of words, if that makes sense. Okay, all right. So guys, right here, I've got a poster. It's 50 square inches, okay? It's got margins of 4 inches at the top and bottom and 2 inches at the side. So let me put these margins in for you to help you out with this. This is going to be 4, and this is going to be 2, and this is going to be 2. And while initially you're going to want to call this whole side x, I'm just letting you know, it's a lot easier to call this whole thing here, this whole length here, call this y, okay, and call this horizontal length here, call this x, okay. Call the insides, if that makes sense. The insides x and y rather than the outsides x and y's, okay. It's going to be much easier. All right. So the question is, I'm trying to minimize the amount of paper used. Okay, so I'm going to try to minimize this whole area. And let's see if we can write the area for this equation. It should be x plus 4 times y plus 8. See if that makes any sense to you. Right? It's the length vertically times the length horizontally. But now I've got x plus the 2 margins and y plus the 2 margins. Okay? Guys, let me tell you what students do, and a lot of students do this wrong. Okay, so I want to make sure you understand this. Okay? When you do margins like this, like a lot of students label this x this side, and they'll put y here, and the y sits right next to the 2. So what they'll do is say y plus 4 and x plus 8. Does that make sense? They'll switch it because it's sitting right next to it. Okay, but the truth is that even if you label the x up here, the x is a horizontal distance, so you need to add the x with the 4. Does that make sense? And not add the x with the 8. Okay, so I'm just letting you know that's a student mistake, a very common student mistake. All right, I want to get this into one variable. How do I get rid of either the x or the y? What constraint? What constraint do I have? 50 is equal to xy. So I have a constraint that's xy is equal to 50. So let's solve for one or the other. Which one do you want to solve for? Should we let Avery answer this time?
Yes.
Okay. Go ahead, Avery. Okay, so y is equal to 50 over x. Is that a beep again? Oh, great. Okay. All right. I probably have never heard Avery's voice. Okay. I probably think it's just a thief's voice. All right. All right. If y is equal to 50 over x, okay. Is everybody good? You just plug in right there. Okay. Guys, at this point, I need to take the derivative, and you have a choice. You can distribute, then take the derivative, or you can do product rule. Which one would you rather do? I can do either way. Product rule? Okay, so let's do product rule. If you do, I hear some sighing out there. Is this a thief's fault again?
Yeah.
Okay, this is probably Brant's fault. Okay, all right, guys, if you do product rule, you need to rewrite this as 50 times x to the negative 1. So here we go. It's going to be a prime, the derivative of the first times the second, plus the derivative of the second times the first. Is everybody good with that? And it's not really as hard. Could be, I guess. It could be harder. So I'm going to write a prime here, and this is really 50 over x plus 8 minus 50 over x squared times x plus 4. It is terrible. Okay, I'm going to distribute this 50 over x squared. Are you guys good with that? I think it'll make it a little bit easier. So this is going to turn into 50 over x plus 8 minus, this is going to be 50 over x. Is that right? Plus 200, minus 200. Who said to do it this way? Okay, so minus 200 over x squared. Is that right?
Yeah.
Okay, so this is going to give me, these cancel out.
Yeah.
No, they don't. No, they don't, because this is, oh yeah, they do. So this is going to be 8 minus 200 x to the negative 2. Okay, so that's going to be your a prime. Not terrible. Yeah, it was terrible. Okay. All right. So guys, here, what do you do after you find a prime? Set equal to 0 or d/e. And in this situation, we actually have a d/e. Do you guys see why? Because you actually have a fraction. So it's going to be 8 minus 200 over x squared is equal to 0, or 8 minus 200 over x squared is equal to 1 over 0. All right? What do you guys want to do on this side to figure out your x, your critical point? Solve for x. So how do you do it, though? Do you want to cross multiply, or do you want to do a common denominator? Okay, so if we do a common denominator, okay, is that Avery again?
Yes.
Okay. So do you see you'll get 8x squared minus 200 over the quantity x squared? I can't, for some reason, I've lost my way to, hold on, where's my little thing?
Right there.
Oh, I've lost my little, like to extend the page, sorry. Yeah, I've lost my little page extension, so I don't know how to extend the page. Okay, it doesn't matter. Right here, when I cross multiply, I'm going to get 8x squared minus 200 is equal to 0. So therefore, x squared is going to be 200 divided by 8. That seems like it should be easy. That's 100 divided by 4, right? Which is 25. Guys, we've done something wrong, I think.
So x squared is 25.
Oh, let me make sure. Oh, x squared equals 25. Yeah, someone said that. Was that a thief too?
That was a beat.
Okay, yeah, x squared equals 25. That's what's good. Okay, because I was like, it should be a solid number here. It's not always, but I knew that it worked out. So x is going to be plus or minus 5. Okay, so x is plus or minus 5. On this side, guys, what's x going to be equal to? Yeah, if you cross multiply, let me go ahead and get the common denominator again here. 8x squared minus 200 equals 1 over 0. If you cross multiply here, it's actually quite simple. you can just get x squared is equal to 0. So therefore, x is equal to 0. Okay? Let me go into here. I'm not sure where the easiest place is. But these are my critical points, 0 and 5 and negative 5. And I'm not going to justify here just because it's so much work. Suffice to say, you can justify in this too, and it'll be in my notes. But I know x is equal to 0 or 5 or negative 5. Guys, do you see that x wouldn't be equal to 0? Is everybody good with that? Okay, because then I wouldn't even have a place to write. Okay, so I'm going to take that out. Let's try, well, x wouldn't be negative 5. Does that make sense? Because that doesn't work either. So therefore, your x must be equal to 5. Okay, if x is equal to 5, what's my y equal to? 10. Everybody good with that? All right, and then let's see if I answered the question. What was the question? What overall dimensions? Okay, so do you see your overall dimensions are going to be 5 plus 4, right? That's your 9. And then your y, it's going to be 10 plus 8. So that's going to be 18. Do you guys see where I'm getting these? Like you have to plug in the overall dimensions. It's going to be y plus your margins. So that's y plus 8. And then the overall dimensions are going to be x plus your margins, which is x plus 4. So this is going to be added to 4. This is going to be added to 8. And your overall dimensions are going to be 9 by 18. And that's your answer. Nice. You like that?